Before start building a PC, we need to have a two important tool. One is ESG safe gloves, but ESG strap is highly recommended, and a good quality full-length magnetic screwdriver, so it will be easy to reach the motherboard screws inside the cabinet. If you are building a PC for first time and you don't know the compatibility of each parts, you can visit the PCPartPicker.com. There you can select the components as per your budget and check for compatibility errors. And also you can see the total power consumption by each parts. It will help to select the right power supply and make sure you select 200 watts more than it recommends. For my build, I have selected Ryzen 3900 XT, a 12-core 24-thread processor. I have selected this processor because I am going to use this only for productivity workloads. And for motherboard, I used Gigabyte B550 AORUS Provision 2, which is also Ryzen 5000 series ready motherboard with 12 plus 2-phase digital twin power design VRM and PCIe 4.0 support. Inside the box we have the user manual and some velcro cable ties and installation disk and few SATA connectors. Also there is a Gigabyte G connector. I will brief about this during the assembly. Then finally some cool AORUS stickers. A noticeable difference between the Vision 1 and Vision 2 motherboard is the front panel USB Type-C connector. For GPU, I selected the RTX 3060 Ti from Zotac. Inside the box, there is a shiny user manual and the GPU itself. Which is very compact twin fan design, and backside there is a 3 display port and 1 HDMI port. And for RAM, I used the ADATA XPG Spectre D50 2x8GB 3200 MHz RAM, which also has the ARGB lighting at the top. And for CPU cooler, I use the Cooler Master Hyper 212 RGB Black Edition, which comes with the single 2000 RPM master fan. There is also an additional bracket to add extra fan for push and pull air configuration. It comes with only 4 heat pipe, I know, which is definitely not enough for this Ryzen 9 processor to run it cooler. AMD recommends to use the AOA liquid cooler for this processor. I selected this only for my budget, and we will check the thermal performance of this cooler at the end of this video. To power all this component, I bought the Gigabyte 750W 80 plus gold certified fully modular power supply, which is more than enough for this build. If you are buying a high rated power supply, then you will have to spend more on UPS too, and lower rating power supply could also end in overloading. So make sure you never compromise on your budget while selecting power supply. I brought the Thermaltake Pure Dual ARGB fans for cabinet. Inside the box there is a ARGB controller, then a few ARGB cables for different types of motherboard and a PWM fan splitter cable. These fans can run at the maximum speed of 1500 RPM. And finally, to put all this component together, I brought the Corsair iCUE 4000X RGB cabinet. This cabinet comes with front and side panel tempered glass with magnetic dust filters at front and top side. It does also have the front panel USB 3.0 connector and also USB Type-C connector support. This cabinet comes with 3 pre-installed SP120 ARGB fans with Corsair lighting node. There you can connect up to 6 SP120 addressable RGB fans. I didn't unbox any storage device because I'm going to use SATA SSD from my old PC. Now let's start building the PC. Now gently pull up the lever in motherboard slightly by pushing it towards the left and make sure you keep it 90 degrees straight and pick up the processor with care. Make sure you don't touch the pins. Align the triangle mark in processor and motherboard socket and place the processor in socket gently. Once it properly aligned, it will fit down without any effort, and never try pushing the processor with hand. Now push the lever down to lock the processor. To install the CPU cooler, look over the instruction manual to select the correct CPU brackets for AMD AM4 socket. I have removed the CPU bracket that comes with motherboard and installed the cooler master CPU bracket. Make sure you don't actually drop the screws into motherboard, it may cause damage to the small sensitive components. I applied the thermal paste that comes with the cooler, and make sure you peel off the protective cover before placing the cooler. And tighten the screws in opposite direction equally to make the thermal paste spread equally. Don't worry about over tightening, the screws will actually stop when it fully tight.
Let's go.
After that, I installed the CPU fan and connected the 12V RGB connector to motherboard and the fan connector to CPU fan header. Before installing the RAM, make sure you read your motherboard manual to install the RAM in correct dual channel slot for better performance. Open the clips in RAM slot and push the RAM down to slot by aligning the pins correctly. Once it installed properly, the clip will automatically lock with a click sound. Don't worry if you don't hear the click sound, sometimes you may need to lock it manually. Pick up the motherboard by holding the CPU cooler and align it with I/O panel slot in the cabinet and place it carefully. In my cabinet it comes with pre-installed standoff for ATX motherboard, so you may require installing standoffs before placing the motherboard. And now secure the motherboard into the cabinet by using screws. And make sure you actually don't over tight the screws, which may damage the motherboard PCB.
Let's go.
I took the required cables for power supply and connected it before mounting the power supply into the cabinet. Now I place the PSU into the cabinet upside down by facing the fan downside and install the screws. Now I connected the motherboard power supply cable and the 8-pin CPU power supply cable. And then I installed the thermal take cabinet fans.
Let's go.
I connected the ARGB fan connector to the motherboard ARGB header and then connected the PWM fan connector to the motherboard fan header. Then I installed the front panel USB Type-C, USB 3.0 connector, audio connector, and finally Corsair lighting node connected to the USB 2.0 header. And also at the back side I also did some cable management with the cable ties that comes with the cabinet. And I connected the Corsair lighting node SATA power connector to the PSU SATA power cable. And now the front panel switch connectors. For this Gigabyte motherboard, it comes with the Gigabyte G connector, which makes the front panel connection easier. All we have to do is just connect the front panel jumper cable connectors to the G connector by referring the markings over it, and connect the G connector directly to the motherboard header. For GPU installation, open the clip on PCI slot and remove the two back panel slots for mounting the GPU, and place the GPU in slot and push it slowly to lock it in the slot. When it locked, you will hear a click sound, so the clip will now closed. By holding the GPU in one hand, install the screws and finally connect the PCIe power connector. Since I brought the non-Wi-Fi version motherboard, I used my old PCIe Wi-Fi card, which is much better than USB Wi-Fi modem. I used my old SATA SSD as a main drive, and I will also be adding 2TB HDD later for file storage. In this Corsair cabinet, you can also mount the 2.5-inch drives on both back or front side based on your preference. I mounted it in front side, so there might be a small air to make the SSD run a bit cooler for longer life. I used the AORUS cable tie in PCI cable to make it look better, and I installed the side panel back for first time testing. Now I turned on the PC for first time and the RGB lights on fan are glowing, and it took 3 minutes to boot for first time. Since I already have the operating system in my SSD, it directly boots into Windows, and I rebooted to BIOS setting and check if all components are detected. Then I enabled the XMP profile to make the RAM run at its maximum speed. For benchmark results, I set the fans to run at its maximum speed to test the CPU temperature at full load and also to get the maximum out of the CPU. I also opened the Corsair iCUE Space application to monitor the live CPU temperature. Since I built this PC only for productivity focused, I will be running the Cinebench R32 test, and also the ambient room temperature was about 30–31 degrees Celsius. In multi-core test at 100% load, the CPU temperature maxed out up to 89 degrees Celsius with 17,600 score, which is 100 points lesser than my previous test without screen recording. In single core test, the CPU temperature reaches maximum 75 degrees Celsius at 10% load, and I got 1270, which is 10 points lesser than my previous test without screen recording. Even with ideal condition, the CPU temperature was around 55–60 degrees Celsius, which is definitely not good for this Ryzen 9 processor. So later I will be adding another fan for my CPU cooler. If you like my video, please hit the like button and subscribe to get notified for more videos.